In this video, we want to solve a rational inequality. Here we have a rational function compared to 0. We want to know where that function is strictly negative. The method that we use builds on the method that we used for polynomial inequalities. Recall, if we have a polynomial compared to 0, then we find the zeros of the polynomial, put those on a number line, and then test subintervals. Now, the reason that that worked for polynomials is that polynomials are continuous everywhere, and so they can only change sign at their zeros. A rational function is continuous everywhere except at x values that give it vertical asymptotes or holes, right? So a rational function can change sign from negative to positive or vice versa at its vertical asymptotes. So the only change that we have to make to our method for polynomial inequalities is to not only put the zeros on our number line, but also put the x values that make the denominator equal to 0 on the line as well. So let's go ahead and go through this example. First, we want to find the zeros. The zeros for this function. Just set your numerator equal to 0. In this case, obviously, we just get x equal to 0. We also want to find the x values that make the denominator equal to 0. So set our denominator equal to 0 and solve. Clearly, negative 2 and 1 will make our denominator 0. So we're solving a rational inequality. We have to put our zeros as well as the x values that make the denominator equal to 0 on the number line. And then test the subintervals just like we did with polynomials. So we can test 2 in the rightmost interval, positive over a positive times a positive. A rational function will be positive from 1 out to infinity. Test 1/2 in this interval. We get a positive divided by positive times a negative. So our function is negative between 0 and 1. Test the negative 1, we get negative over positive times a negative, which is positive. And then the left interval, let's test the negative 3. Negative divided by negative times a negative. So our function is negative in the leftmost interval. We want to know where our rational expression is strictly less than 0. So the solution, according to our number line, is negative infinity to negative 2, union 0 to 1. We use parentheses at our endpoints because we're solving a strict inequality.